make that recording on. Okay, so 8255 IC, if you look at the IC, this is the IC actually, 8255. You can see P8255A. So mainly if you look at the number 8255 IC, so it is 40 pin IC. So out of 40 pin, most important thing is 3 port and 1 control register, 3 port actually. Control register is inside the, I mean, we don't have to control register pin, it's pin, they should not be out, I mean there should not be separate pin for control register. Okay, so look at the, so you can see PA3, PA2, PA1 and PA0. So this is for port A actually, port A 4 bit, and where are the other 4 bit? You can see here PA7, PA6, PA5, PA4. So 448. This 8 pin for port A. And then you can see for port C, here they are together actually. PC, you can see here, this is for port C. PC3, PC2, PC1, PC0, and then PC4, PC5, PC6. They're in different order, not they are all in same order. Okay, doesn't matter. So this is for port C. And port B, you can see PB0, PB1, PB2, and then PB3, PB4, 5, 6, 7. So this 8 pin for port B. We already know it that there are 3 ports and 1 control register. Control register inside there. So, and we have it has 8-bit data bus. I mean 8-bit data port. Okay, because data communication it can done 8 through 8 bit. Okay, so 8 bit is it doesn't, not more than that. And 1 pin is for BCC. You know, like all the digital IC, they must have a BCC pin and ground pin. So you can see the BCC and ground. Okay, so this is done. Okay, look at here, most of the thing. And 1 is reset pin. We already know the reset for make the things restart again. Okay, reset pin. And 1 pin is for, you can see 1 pin is for write operation, because you know sometimes if we have the output port, we need a write operation. If it is an input port, we need a read operation, you know, so read and write. So this 2 pin we need it here. But so out of this, I mean out of all except these pins, we have few pins left. These are the important things. You can see A1, A0, A1 and A0. So this A1 and A0 together with chip select. You can see another pin is chip select. Chip select. So chip select and A1 and A0. So these 3 pin actually determine the address. You know that in the lab, what are the port addresses? If we use the, I mean, if we use the 8255 that is connected with P1, then the port addresses they were 00, 00H, 02H. You can remember, right? 02H. This is for port A, and this is for port B, and this is for port C. Yeah, for 04H, and control register is 06H. Okay, so this is for the 825 IC that is connected with P1, but for P2 it is different. So here actually this chip select signal and A1 and A0, they actually determine the addresses. We will see it how actually they determine the addresses. Okay, so I mean, and also another thing is here, it works in a group also. We can work in a group, like you can see group A. Inside the group A we have a port A and port C upper. You can see PC4 to PC7. I said in the lab class that port C it can be used 4 half. Okay, so PC upper, I mean higher 4 pin of PC port C, and this is in a group A. So group A includes port A and PC upper, and group B includes port B and PC lower. We can also work as a group also, or we can work as a separate, so it doesn't matter. Okay, and so now this is basic information. Okay, let us go. So chip select, you can see that chip select pin, this pin as with a bar, that means if it is 0 then it is active. Chip select pin, you can see chip select pin, it is with a bar. And in a digital course, you already know it, all the digital IC, if something is with a bar, that means it is, or sometimes if there is a bubble sign, that means it is active. If it is low, it gets the low signal, 0 signal. Okay, so that means a low signal must be there to activate, to select the chip, to activate the chip. Okay, now if you look at here, so so chip select signal, it must be 0. Okay, and if A1 and A0, if they are 0 0, then it is for port A. If A1 and A0, if it is 0 1, then it is for port B. If A1 and A0, it is 1 0, then it select the port C. And if A1 and A0, it is 1 1, it select the control resistor, not the control word. I think it's better control word or control resistor. Okay, control resistor. Okay, so we must have the chip select pin low, including the low. We must have, we know that so if A1 and A0, these two pin, if it is 0 0, it is for port A. If it is 0 1, for port B. If it is 1 0, for port C, and 1 1 for control resistor. Okay, all right. So then, and mode, I said that mode, there are different modes actually, mode 0, mode 1, and mode 2. So basically, we normally, all the basic input output mode is mode 0, and for this case M is 0 or 00. Mode 1 and mode 2, actually, if we could manage time, then we will cover, discuss these two modes also. But I think maybe the semester is shorted, semester becomes short now. Anyway, so mode 1, there are also other two mode. It's called strobe input output mode, and by it is a little bit difficult issue. So not difficult too much, but not the simple input output mode. Okay, so for simple output mode or basic input output cases, like what actually we are using in the lab, it's mode 0. Okay, and what about the control resistor? Control what written in control resistor? I said that control resistor is 8 bit, and this one is for port C lower. You can see PC port C, P C low. Okay, yeah. In lab, during the lab we did. I mean, I wrote it. Okay, and this is for, and this one is for port B. Next one is for port B. AB. Okay, and then next one is for mode. Okay, and then this 3 bit actually related to the group A, group B, sorry. So even if it is not necessary group A, group B here, but just for information. And D3 for PC, PC, that one is for PC low and PC high, PC up, you can say PC upper. And then this is for port A. And then next 2 bit, this 2 bit, it is for mode, and this one is default 1. Yeah, this is for active 1. It is always 1. Yeah, this is same like what we said in the lecture lab class, you know. So PC low, if it is input then 1, then output 0. Port B also, if it is input then 1, output 0. And mode, for simple input for mode 0, it is 0. So we use normal simple number. So that's why we keep this one always 0. This mod always 0. This one always 0. Okay, and then port C upper, if it is if input case, then 1, output case 0. If not use case, don't care. Port A, if it is input 1, output 0, not use, don't care. And mod, here it is this 2 bit is for mod, and for simple mod 0 it is 0 0. Okay, yeah. What, Abdulhati? I do not get you. For mod, yeah. So these two, D5 and D6, these 2 bit is for mod. So this mod, if it is a simple input or mod 0, then it is 0 0. So I said that in the lab. So for normal in operation, we use it for simple input output cases are there. So mod 0. So this is 0 0. And mod 1, mod 2, this is complicated issue. So I think we do not get time to manage it. Okay, mod 0 0 0, and this one is active 1. This is always active 1, and this 2 bit is 0 0. Okay, so this is the control word to be written in control register. So is the yeah, this is about it. Okay, now it's about the addressing. If you look at here, for example, chip select signal, if you look at here, chip select signal, it is connected. So it is with a bar, and also definitely there should be a bubble. You can see there is a bubble. So okay, and it is connected with the output of the NAND gate. If you look at here, it is connected with the output of a NAND gate. Okay, yeah, it's bigger now. Yeah, so if it is connected with the output of the NAND gate, and now NAND gate, what are the inputs in the NAND gate? You can see A15, A14, they are directly connected here. A13 until A2. That means all these pins, they are connected with the NOT gate. So this is actually basically NOT gate, a bubble and a inverter sign. That means it is a NOT gate. Or we can also, yeah, if you look at here, it is with a bubble and inverter sign and in a buffer sign. That means it is a NOT gate. Or NOT gate also we normally write it this way, right? And this is also a NOT gate. So all are okay. Anyway, so we also write the NOT gate this way. So this is same as like this one. So NOT gate is A2 to A30. And also look at here, there is another input. It is input output slash memory bar. That means it can work for input IO. IO means input output case if it is 1. If it is 0, then it works for a memory related operation. Okay. So that means this input, this pin, it can work in both ways. If it is 1, then it works for input output cases, and if it is 0, that means it works for M. M means for memory related operation, not input output related operation. Now look at here. So as it is a NOT gate, so we know that when actually you get the output of the NAND gate, this NAND gate, when all the pins are 1, here it is all the inputs are 1, all are 1, all are 1. Okay, all are 1. If all the inputs are 1, here also 1, then we only get 0 here. Is that right? Yes. So all the inputs must be 1. Then we can get the output of the NAND gate 0. And then this 0 means it actually activate. It chip select. It is connected with the chip select. That means it actually select the chip, or it actually activate the chip. So now look at here. If all the pins are 1, so here, but look at here, A15 is directly connected. So that means it must be 1. A14 is directly, it must be 1. But output of this NOT gate, it should be 1. That means they should be 0. All the things, they should be 0 until A13 until A2. They must be 0. Is that clear? Is it okay? Yeah. So because NOT gate, output of the NOT gate should be 1. So that means input should be 0. So then what will happen? We can write it a bitwise, like A15. This is for A15. A15. Okay. Okay, let me write it separately. A15. A14. A13. And then A12. Okay, so it is for addressing, finding the addresses of the ports. Okay, so 8-bit in 16-bit is an see here for addressing 16-bit. So 12, and then so address bus we need 16-bit address bus. So that means we know that microprocessor address bus has 20-bit. That means higher 4-bit they are not they are not used here. A11, A10, A9, A8. And then A7, sorry, A7, A6, A5, A4. So when you determine the address, write it in this format. Okay. So and then A3, A2, A1, and A0. Okay, now look at here. So A0 to A15, so 16-bit addressing. Now look at here. What are the conditions here for chip select? We said that chip select and A1 and A0, they actually determine the addresses of the ports. So chip select, it must be 0. So it must to make it 0. We can see that A15 and A14 they should be 1. They should be 1. And A13 to A2 they all are 0. And if they are 0, after the NOT gate, they will be 1. That means this is 0, this is 0, and then this is 0, 0, 0, 0. And here also 0, 0, 0, 0. Until A2. Okay, 0. So that means until A2 it is written. Now it's about A1 and A0. So A1 A0, we know that they can be 0, 0, they can be 0, 1, they can be 1, 0, and they can be 1, 1. Okay, so that means this yeah. Okay, so now yeah, so look at here. So if A1 and A0, if it is 0, 0, that means it is for port A. It is for port A, addresses of port A. And then next one is for port B. Port B. Next one is for port C. And next one is for control register. So sometimes some book they use control. I think it's control register is good, or control what it is said. Control register, okay. CR control register. Okay. Now look at here. What is the address here? Look, this one is for this one is actually 1100. It is C, and then 0000 it is 0, and 0000 it is 0. And here if A1 A0 00 it will be 0. So that means port A address it is C 0 0 0 H. This is for port A. H. Okay. And then what is the port's B address? So A1 A0 01. Yeah, C0001. Yes, you are right. C00 C 0 0 0 1 H. Okay, and this is H. Okay, and then port C address 2 C002. So it's next to each other. Okay, you can see that they are. I mean, their numbers are just C0001 2 0 0 1 0 2 so on. And what will be the control register address? C 0 0 3. Yeah, so this is about the addressing. So now is it clear, right? If the chip select actually if it is like that, then this is the way we can find the addresses. And what about you can see input output of the memory bar, it is not directly related to the addressing here, but because you know, like as it is for input output, so we use the port A, this IC actually is for input output, external input output cases. Okay, external devices, input output cases. That's why it must be one. So this is not directly I mean directly used for addressing, but it can be. I mean, it can be. We can connect it for getting the chip select signal also, because for in memory related cases we do not need the 8255 IC. Yeah, so that's why. So memory, if it is 0, that means it is for memory related operation. So we do not use it for memory related operation. This is not directly used for addressing. And so addressing is because address pin, all the address pins, you can see A for address pin. These are the pins available from the microprocessor. Microprocessor has 20-bit address pin or 20-bit 20 address line, you know, A0 to A50, A19. So out of 20 address line, 16 we can use them here. Even, you know, like sometimes we do not use all of them. So maybe we can put them 0 or don't care or 1, doesn't matter. Let's see another example. So this one is okay. You understand how to find the addresses of ports and control register. Okay, so it is very basic about the 200, you know. Let's see one more example. Yeah. So look at here. Okay. So now you can see the chip select signal. This chip select signal is here. And I said that just we need the A1 and A0. What are the signals connected of the IC of A1 and A0? You know, like this 8255 IC, I said that it has two pin A1 and A0 and chip select signal. These three pins are responsible to determine the addresses. Now look at here. So in the previous cases, in these cases, you can see the A0, and this A0 is the pin of the IC. This A1 is the pin of the IC. This A1 is connected directly with A1 address line, and A0 is directly connected with A0 address line. But it can be different. This A1 may not be connected to A1 of microprocessor address line, and this A0, it may not be connected to A0. Okay, let's see this the second example here. So look at here, this A0, it is connected with A1. You can see B doesn't matter, B for bus here, bus address line. And A1 is connected, you can see A1 is connected with A2. Okay, so microprocessor, I mean 8255 IC, I said that it has A1 pin and A0 pin. So A0 pin is connected to A1 address line, and A1 pin, it is connected with A2 address line. Is that clear? Is it, do and get it? Okay, and what about the chip select signal? Look at here, chip select signal. It is, so previous case, it is connected with the output of the NAND gate, but here it is not the NAND gate. Here it is 74, you can see 74138. Just number, look at the number 74138. It is a 3 to 8 line decoder actually. 3 to 8 line decoder. So the decoder has 3 input pin and 8 output pin. You know already what is decoder. Okay, so 200 in E200 you got it. So 3 to 8 line decoder. So inputs are these 3 pins are input. Okay, ABC or ABC or one, it doesn't matter, ABC for example. And output are this output pin. You can see they are the output pins. They are the output pins. Basically, actually, this 15, 14, then it is not an important issue. Output pins are, you can see this one is Y0. This is Y0, the topmost one, Y0 with a bar, with a bubble. Actually, everything has at the end bubble. And this is Y1. We have with yeah, okay, and this is Y2 and so on. This is Y7. And they has, you can see they has a bubble at the end. That means it is active. Active means it is 0. So if this pin is active, means there is a 0. Okay, so this is about the 3 to 8 line. So input, we have the input is connected to ABC. So C is MSB actually. Basically C is for MSB. We can say this is for C for MSB. It's like that. Okay, C, B, A, C, B, A. Okay, and okay, now look at here. So C is A is connected to A3. If you look at here, this A3, A is connected to A3, and B is connected to A4. So this is A4, A4. This is A3, and C is connected with 5, A5. This is A5. Okay, so look at here, and output, look at here, output, we have 8 outputs. So we actually get the chip select signal. You can see the chip select signal, it is connected with Y1, output of Y1, not Y0, Y1. So that means when it is 0, 0, 0, then actually we get a active low output in this pin, Y0. If it is 0, 0, 1, 0, 0, 1, we get a active low output in Y1. Okay, Y1. If it is 0, 0, 1, we get active low output in Y1. Okay, so it's so on. So as it is connected with this one, that means we must have A4, A3, A4 and A5. It should be 0, 0, 1. Then we will get a active low output here. Is it clear? Is it okay? Okay, now it's about there are few more things left. It's about the chip select. I mean this 3 to 8 line decoder. It has a enable pin, 3 enable pin. If you can remember, or okay, now we are recalling the things. It has 3 enable pin. One is G1, G2A, and G2B. So G1, or maybe think about it. So one is active low enable pin. So there is no bubble here. That means if it is one, then this is active. If then next two is must be 0 to get it active. So G1, G2A, and G3A. So three enable pin here. So that means the active high one, it must be 1, and active low and active low input enable pin, they must be 0. So if it is like that, now look at here. G1 is connected with A6. G2A is connected to A7, and this one is connected with A1. Sorry, A0. A0 is connected to G2 bar. So now what will be the address? Now look at here, and rest of the address pins are not connected here. So first of all, let us write the address pin here. Okay, let me write it here. This is A15, A14, A13, and then A11, A10, A9, A8. Okay, then A7, 6, 5, A4, and then A3, A2, A1, and A0. Okay, so this is about the address pin. Samsa, Sami Samsa, Dean. If go Shida there. Yeah, this corridor. Last, nothing. I don't know then. Okay. So now, yeah, this is about the address pin A0 to A15. Okay. Now look at here. We do not have, so A15 is not used here. So if something is unused, we can write them 0. We can write them. Okay. Yeah. So 0, and A14 also is not used here. So 0, A13 also not used here, and A12 not used here. Then now A11, it is also not used. A10 not used. A9 not used. A8 not used. Okay. Now A7, and from 7 it is used here. So 7, you can see, as you can see, 7 should be 0 or 1. A7, it should be 0 or 1, because it is connected with active low enable pin G2A. You can see there is a bubble. That means it is a active low enable pin. It must be 0. So it should be 0, right? 0. And then A6. What about A6? A6 is connected to G1. G1 is an active high enable pin. So it must be 1. And then A5. A5, it is, you can see here, A5, A4, and A3. They are the inputs, 3 input pin of the 3 to 8 line decoder. And we already discussed that. So if it is, you can see C is the MSB pin. So it is connected with A5, then A4, A3. So that means it must be 0, 0, 0. Sorry, it must be 0, 0, 1. Then we will get a active low output pin on Y1. Okay, so that means it must be 0, 0, 1. All right, it must be 0, 0, 1. This one is 1. Okay, let me write another color. Hopefully that will make it easy. So this one must be 1. Okay. Now, what about the A2 and A0? They are actually connected with A1 and A0. Okay, so they are variable. And what about the A0? A0, you can see here it is connected with the 5 G2B. G2B. A0 is connected with the one of the active low enable pin. So it must be 0. Okay. So that now look at here. So we have the variables. Yeah, look at here. So we have the variables now, A2 and A1. They are the variables, right? Here it is 1 actually. It is 1. See, A3 1. So A3 1. Okay. So now look at here. So these variables, they can be 0 0, they can be 0 1, and they can be 1 0, or they can be 1 1. Okay. So the pins that are not used, you can keep them 0 or you can keep them don't care. I think don't care is better. Okay, keep them the don't, because they are don't care cases. So A12, A13, A14 and A15, they are unused. And same like A8, A9, A10, A11, they are don't care cases. Okay, they are unused. And then again I am repeating, A7, you can see A7 is connected with active low enable pin. So definitely it must be 0. Okay, definitely it must be 0. Okay, and what about the A6? A6 is connected to active high enable pin. It must be 1. Okay, it must be 1. And then A5, A4 and A3, they are connected with the inputs here. You can see inputs. And this input, it must be, if it is 0, I mean, yeah, 0 0 1. If it is 0 0 1, okay, because C is the MSB. If it is 0 0 1, we will get an active, I mean, output signal on Y1, and this is definitely as they are ending with a bubble. Actually, it is not clear, very clear, but it is ending with a bubble. So that means active low output we will get only when yeah, on Y1 if it is 0 0 1. So that means then we will get a active low. So that means definitely it should be 0 0 and 1. Here it must be 1. A3 must be 1. Okay, and then what about the A0? A0 is and our variable is A2 and A3. A1 and A2, they are the variables, two variables. Okay, because they are connected with the A0 and A1 pin, A0 and A1 pin of the 825 All right, and what about the A0? A0 is also used here. It is not don't care. It is also used here, and it is connected with active low enable pin. You can see this one, active low enable pin. So it must be 0. Now let us determine the addresses. So variables are A1 and A2. We can write a vertical line, so that it is 0 0 0 1 1 0 1 1. So this is for port A address, and port A address is now what? If don't care cases are 0, that means 0 0, and here it is 4, and then this is 1. Okay, so 1 0 0 0 8. So that means 0 0 4 8. So port A address is 0 0 4 8. And then you can see if it is then for port B it is again 0 0 4, and here it is 1 0 1 0. So it will be 2. Sorry, 1 0 1 0. It is A, right? 1 0 1 0. It is A. So port B address is 4A, and same way port C address is 0 0 4 C, and control register address it will be 0 0 4 E. Is that clear? Is it okay? Yeah, so this is about like that. Yeah, so yes, so you can see what I said you, it is written here actually. you can see. So these two pins actually A1 and A0. So you can write in this format actually. What I written here, you can write this format and that will be okay. Okay, this is the way actually we have to find the addresses. So I mean, chip select signal, it may be connected with the output of the NAND gate, or it may be connected with the decoder IC. So decoder IC also very commonly used IC. Yeah, it's like that. Now what is the, you can see the difference between this example and previous example. So it's about the variable. If the variables are A1 and A2, then actually you can see the difference between port A, port B addresses are 2. Like you can see this is 4A, then 4A, 4C, it's 2 gap, 2 gap. But if variables are A0 and A1, then the previous cases the gap is 1. If port A address is 0048, then port B address will be 0049, port 4A and 4B. It's like that. So one gap, but here it is a 2 gap because here the variables are A2 and A1 and A2. Is that clear? Is it okay? So today actually the discussion is about finding the addresses of port A, port B, port C and control register. So if we can find the addresses, if we have to think three pins. One is the A0, one is the A1 and one is the chip select signal. So this 3 pin is responsible for determining the addresses. Let's see one more example, then I'll finish. Okay, look at here in this case. So we are not discussing any program now. So I'm just only finding the address. Look at here. What are the cases here? You can see here A0 is connected with A1 and A1 is connected with A2. Okay, fine. So that means so responsible two pins are A0 and A1 and chip select signal. Okay, so chip select is connected with the NAND gate, input of the NAND gate, and in NAND gate has the input A10, A9. Okay, so let us find the address. What will be the addresses? Okay, so let me write it. Start from here. A15, A14, A13, A12, then A11, A10, A9, A8, then A7, A6, A5, A4, and A3, A2, A1, A0. Okay, now look at here. Look at here. So A15, it is unused here. So A15, it is unused. So we can write it, don't care. And A14, it is also unused. We can write it, don't care. Then A13, 12, they are also unused. We can write them also, don't care. Okay. Then what about the A11? A11 is also unused. A10, look at here, A10, A9, A8 and A6, they are used here, but as it is NAND gate, when actually we get the active low output, if all the inputs are 1, right? All the inputs are 1, then only we will get this is the only one condition. Then we'll get the outputs 0. Okay, NAND gate. So that means, so A9, okay, so A9 it must be 1. Sorry, A10 it must be 1, A9 it must be 1, and A8 it must be 1, and A7 you can see A7 is unused, so leave it, keep it as a don't care. Okay, and then A6 it must be 1, A5, A4 they are unused. What about the A3? This is also unused. And A2 and A1 they are connected with A0 and A1, so they are the variables. They are the variables. Okay, and what about the A0 also unused, so it is don't care. Okay, now it's about the port. So that means A1 and A0, they can be 00, 01, 10, or 11. Okay, now it's about the port A address. What will be the, if don't care cases are all 0. Okay, so then 0, 7, here it is 4 and 0. So 0, 7, 4, 4, 0. 40 has. Okay, 0740. Yeah, 0740 has. It is for port A. What will be the port B? Even without looking it, we can directly write what will be the next one. Can you tell me? 0742 it will be, because here the variables are A1 and A2. But or you can check it here. Check it here. So this will be 0, this is 7, this is 4. But here it is 0, 0, 1, 0. So it will be 0742. Is that clear? You get it? Yeah. Do you get it? Yes. So then what will be the, yes, it's okay. So hopefully all of you. So the next one will be 07444 and 0746. That's it. I'm not going to about the program. So just it's about the addressing. So today is it clear? Finding the address. Okay, so now let me review. Let me say the syllabus. Okay, syllabus of measure 1, measure 2. So measure 2, I said you that control flow instruction. Okay, let me write it here. Okay, let me open it. Yeah. So measure 2 syllabus. now look at here. This is about the Measure 2 syllabus. It's on Thursday. Time. Okay, let me write it. So it's on Thursday at 12 p.m. Okay, so online. So so first one is control flow instruction plus yeah. So this is like a quiz, you know, quiz number 3. You know that how what sort of things you got it in quiz 3. Okay, then from arithmetic and logic instruction, some logical instruction. Arithmetic instruction is basic, you already know it. Logic instruction like rotation left, rotation right, shift left, shift right, and then NOT gate, XOR gate, AND gate, OR gate. These are the things. Okay, so kind of like that. And then machine code of a program. It is like today's quiz, right? Quiz number 4, and homework also is given, so practice them. Yeah, finish the homework also before the measure quiz. I will put a link. If link is not there, I will put a link. So don't send me on email. Send me on Blackboard. Quiz 4. Quiz 4. Yeah, quiz 4 and homework 4 also. Homework 4 also. Homework 4 is deadline before the measure 2. So okay, finish it before the measure 2. Okay, so it's like a quiz 4 or homework 4. Okay, and now it's about the 8255 IC and input output interfacing. So basic example like experiment 4 and experiment 5. So basic example, you know it, right? So of lab manual, experiment 4 and 5, last 2 lab, we will already discuss it. Simple cases actually, and lecture of today about finding addresses. So today actually we discuss about different type 3 example about finding addresses. So it's about finding addresses of the ports, because you know when actually we write the program like experiment 4 and 5, simple example, we need the addresses. So in the lab during the lab class, addresses are fixed. I said that addresses are given, but now if it is not given, then we have to find it. Okay, so looking the hardware connection, we can find it, like the circuit, like the looking the circuit connection, we can find it. So this is all. So this is about the Measure 2 syllabus. Any question do you have here? No. Okay, fine. So then let me upload the, yeah, Dr. put 2 attempts at least for quiz in case getting error or disconnected. Okay, fine. Okay, so give me 5 minutes. You can start it at 11:05. Give me 5 minutes, and I will upload it now. Okay, so see you for today. Inshallah, tomorrow lab class. You know lab class tomorrow. Okay, let me. Yeah, is there any? Yeah, tomorrow also we have a lab class. Okay, online. So all of you at the same time, 2 o'clock. Okay, all of you at 2 o'clock. So yeah, yeah. So get ready. I mean, I will put the link. I will put the link on lecture class, because you know lab class we have many groups, at least 2 group we have. So 2 group, but we want as it is online, so we can start at the same time. So 2 o'clock it is the link will be given from the lecture class. Okay, so join in the lecture class. Join from the lecture class. You can see the lab on Monday, something like that. You will get it. So all of you, because attendance is important, so don't I mean don't miss the attendance. Okay, so this is about tomorrow's lab. Any question do you have about the lab, tomorrow lab? 2 o'clock. Okay, so all of you supposed to be available on 2 o'clock. Is that fine? Okay, okay then.